Hey guys, this is Joe again, and I'm going to talk about the same problem again, dealing with currents but using a current divider. Now, before going into the actual problem with this circuit, I'm going to explain what a current divider is, and hopefully this should help. Okay, so basically what a current divider is it allows you to find a current. For example, we have a current here, I.O., that we would like to find, and we have a current source, IS. And we have a bunch of resistors in the meantime. Now, we could have other currents that go up and down. Basically, for example, if we had another current that was also taking away from the source current, we would have to take the difference of IS minus, if we called this one like IZ, whatever, minus IZ, we'd have to use that as the current source. The new current source would be that. But that's jumping ahead of myself. So let me go ahead and explain to you guys what we need to do first. So basically we need to find out what is I.O. So in order to find I.O., it works pretty similar to the voltage divider. But the first thing we need to do is find the equivalent resistance that does not include Rx. And the reason is because I.O. goes through Rx, so we need to treat it separately, because just like a voltage divider where we find a ratio of resistance, we're going to find another ratio of resistance. It just works a little bit differently. Alright, so basically what we would do is we obviously have to find I.O., so we need to know I.O. equals something. And just like in a voltage divider, you use the voltage source to multiply by some sort of R equivalency or some sort of ratio. So we're going to do the same thing. So IS, which is the source, and we're going to multiply it by R equivalent divided by R equivalent plus Rx. And this is the general equation for that. So basically what this means is R3 and R2 and R1 are in parallel. So basically we have to say that for this block of the, which would be our R equivalent, we would just call that R3 in parallel with R2, and then this is in parallel with R1. And this is equal to our R equivalent. And basically, whatever number you get out of this could be, let's just say it's 6, and then let's just say that Rx is 2. So basically how that would work is, and let's just say our current source is 6 amps. I.O. in this case would be equal to 6 times 6 over 6 plus 2, which is equal to 36 over 8, which is equal to what your I.O. would be. Alright, so with that being said, let's move on to our problem. Let's see what happens when we have our circuit. So before I was mentioning that we need to find I.O., which is right here. I.O. comes down here. But I also mentioned that if we have other currents and not a resistance, for example, this branch is represented by some sort of current, even though we know if we find the voltage and we know what the current is, we can kind of figure out what the resistance is. Just by doing this problem in the past, I know it's 8 ohms because it's I.O. over 4 is also in this branch. And if that's I.O. over 4 and that's I.O. over 4, that means that this should also be 8 ohms. So with that being said, we don't know what that resistance is, and we'll just assume we don't know what this resistance is. But all we know is that it's a current. And this current is taking away from this current. So this is the current source. So 9 amps is equal to IS, the current source. So basically what we would want to do is, if we know that there's a river that has 9 amps worth of water flowing through it, and I.O. of it is taking away from the 9 amps, and I.O. over 4 is being taken away, and then whatever this current would be, which we already in past problems figured out, is I.O. over 4. So basically whatever goes in must come out. So with that being said, if you're using a current divider and you have a mixture of currents and resistances, you could theoretically just use the currents and resistances you currently have and not have to worry about finding a resistance, for example, for I/O over 4. And the way that works is we said that the equation for I/O is equal to IS times some sort of R equivalence over R equivalence plus whatever your resistance for the current is. So we'll call that Rx, which in this case is 2. But IS, what is IS? It's not, in this case, it's simply not just 9 amps. What it is I/O is equal to your 9 amps, but you also have to subtract, because 9 amps is going into the circuit, but I/O over 4 is going out of it and going to ground, which means that you need to subtract I/O over 4. So it's the current differences. So if this was a resistance called R2, we wouldn't subtract it. But since there is another current and it's going away from this 9 amps, so the 9 amps is going in, but the I/O over 4 is going out, you subtract it. If I/O over 4 was going in, so if it looked like 9 amps and then I/O over 4 is going in, then you would actually add 9 plus I/O over 4. But since, like I said, it's a difference between the two, we know that basically all of the current isn't 9 amps, it's 9 amps minus the I/O over 4. Okay, and R equivalent in this case is just 8 ohms. And the reason it's just 8 ohms is because you don't want to say it's in parallel with 2 ohms, because we need the 2 ohms as Rx. So 2 is equal to Rx, and R equivalent is equal to just 8 ohms. So with that being said, you have 8 over 8 plus 2, and then you have to distribute this, so then you got basically I/O is equal to 9 times 8 over 10, and then you got, let's just take the plus, so we got minus, which we can bring over to the right hand side, so we'll just say I/O plus another I/O over 4, but that's multiplied by 8/10 as well. Okay, so now you have a left side of the equation, a right hand side of the equation. So we got 72/10, or which is just 9 times 8 over 10, is equal to 8 times 4. So these two can cancel actually. So then you get 2 I/O over 10 is equal to, or excuse me, 10 over 10 I/O. So basically 12 I/O, and then basically divided by 10 is equal to 72 over 10. The 10s will cancel. So then your answer would be I/O is equal to 72 divided by 12. So basically if you bring up the calculator and you just say 72 divided by 12, and you get 6 amps, and that's exactly what I/O is 6 amps. So this is a lot easier to do for me anyhow. It's a lot more intuitive for me. It's a lot easier. You don't have to do any source transforms. You don't have to find out really any relationships. You just take what you have in front of you and you use the equation and you go with it. So if you guys have any questions, this is exactly like the first time I introduced a voltage divider, where I said, all right, well, we'll just take the voltage differences for the voltage source instead of just finding out what the other resistances are. Same exact concept. We know that there's a 9 amps coming out. We know there's an I/O over 4 coming, 9 amps going in, I/O over 4 coming out. So if you take the difference between the two and then you do your R equivalents, you should be able to find what the current I/O is. And in our case, we were good because our R equivalence actually was 8 ohms, and that's what made it easier, is we didn't have to do anything in parallel or series or find any sort of equivalencies. It was right there for us. Alright, well, I want to thank you guys for watching, and you guys have a great day. If you have any questions, just leave them in the comment section.